The interconnection of all our devices and our reliance on them for almost every aspect of our lives brings a whole new range of threats to our personal data, identity, safety, and even our very ideas. Embedded security continues to be a key area where we as engineers must focus our attention to ensure our systems are bettering the world around us and not providing gateways for bad actors to misuse our designs, to hurt our end users, or steal our own intellectual property. How secure can we truly make our systems, and what tools and methodologies are available to us to keep our designs safe? So as we at Future have had a chance to work with many engineers on their different designs, we get to see the success stories of that. The unfortunate reality of it is we also get to see a lot of the horror stories of these designs. And lately, a lot of those horror stories in design have really focused around the idea of insecure embedded systems where hackers have been able to steal intellectual property and create a low-cost alternative, which has ruined the business model for companies and their designs. We've seen where bad actors have been able to upload firmware into a product that was never meant to run on that product and use that firmware to cause damage, to misuse the device or other things that can cause a lot of problems. Or worst case scenarios that we've seen are where an innocuous wireless device is hooked into another network that was never meant to be accessing secure information, but somehow hackers have been able to use that device to get deeper and deeper into the network, access financial data, access very, very secure data that have caused enormous problems for the end users and for the company that created the initial design. With all of these different challenges that are starting to pop up in embedded systems today, we've got to take this into consideration. And we're seeing governments around the world also starting to write and pass legislation that's going to impact the way that we design our systems. So there's a lot more we've got to be taking into consideration in our designs right now, and we've got to be looking for experts in the industry that can help us with that consideration. Today I have the opportunity and the privilege to speak with Xavier Bignalet, who's the product marketing manager at Microchip of their wide array of different secure devices, and is an expert and someone that's spent a lot of time helping other engineers with the securing of their systems. Xavier, thanks so much for joining me on The Current today. Really appreciate your time.
Yeah, thank you for having me, Todd.
So, would you mind maybe sharing with me, without giving away any names, of course, maybe some of the horror stories that you've seen out there in the industry where security has really been abused and hasn't happened in the system and designs have been misused?
Yeah, I'll actually give you 3 examples. The first one will be, it's all public facing. It's that big DDoS attack that happened in 2016. I'll give you actually another one. If you remember the Heartbleed attack back in 2007. So that's the scary thing. It was brought out to the public in 2007, but still today engineers are fighting it. So think about it, when 2023 you get a span of 16 years, we're still paying the price for this bug. So that's the nature of the beast when you get connected system. Connection means you can scale your attacks, and that's the danger of it. So a lot of things to take care of. The second example, I'm going to step out away from IoT and talk to you about the notion of product protection, counterfeit protection. So there are quite a few markets in the consumer, the medical, quite a bit on the medical side, that has that notion of disposable. So that's where, imagine the cartridge business model, essentially, when you have your liquid, your gas, your gel, and that's where the big gross margins are. So they want to protect that. And as volumes are going up, that becomes a financial target for, their competition that would come and counterfeit those type of things. Look at e-cigarette stories and legislations. There's a ton of content publicly, and make your own opinion there. But that ties very quickly to legislation now. Again, volumes mean consumptions, means target, means problems, right? So there are things to be taken care of there. And the third one is IP protection. So when a company has its IP stolen, so the IP quite often, if not most often, relies on the firmware itself and the mechanics of the products, really. So the firmware that runs the mechanics, I'll give you the example I have in mind right now is a metal detector. So the company reached out to Microchip actually to help them out because they were under that dilemma. And to be honest, I don't know if the company is still alive today. So that's
Oh, wow.
so bad. It didn't take them very long. I think it took them about 24, 36 months to be in a bad shape. And here you go, right? You wait too long, you're gonna have some drastic consequences.
Yeah, yeah, and certainly, a company potentially shuttering their doors is at the extreme end of that. So definitely terrifying thing. Is there something you've seen, just in general, a common theme to what embedded engineers are overlooking when it comes to securing their systems?
Yeah, absolutely. It's completely ignored, completely ignored, or
Yeah,
completely ignored. If not ignored, it's an afterthought. So it's very, I'd say it's a historical pattern where if you look at all the consortiums out there in the world of IoT, it's connectivity first. You take care of your connectivity and
yep,
how the protocol is supposed to be. And when things are somewhat stable, so you're into maybe version 2, version 3 of the product, so then security, okay, now we really need to look at security. Because right now, so far, they've looked at the encryption, the exchange mechanism, which is part of security, but it doesn't help you much if you just rely on that. That doesn't help you at all. It's a good foundation, necessary foundation, encryption, but it's just not security on its own. So that's what we see. It's gotten better. The other problem is it ties to that. It's education. It's just a huge lack of education, right
right,
from when young engineers leave university. University programs have matured a lot for the past, I'd say, 5 years. So it's better and better. You see the implementation of security by engineers from the big industry like automotive, consumer is getting slightly better. The challenge with customer, they have big cost trade-off.
right.
So security is gonna take a dent because of cost very often if regulations are not there.
Right, right. And I think it is, what I've seen is exactly what you said is, the challenge is engineers not really taking into consideration. There's been no planning for security from the
That's
early side
correct.
of the
That's
design. That's
correct. Yeah.
exactly what I've seen. But I kind of look at it and I say, okay, if I'm a design engineer for a company and my boss is not mandated that I secure the system, my CEO is not mandated that, or I don't have a governmental entity mandating that, so I don't have to do it. Going to my upper management and saying, I need to spend another 50 cents on our BOM to get a secure device. I need to spend another month or 2 months on the system design to secure it. That might be the right thing to do. And from an ethical responsibility for us as engineers, it probably is the right conversation to have. But there's a little bit of an intimidation factor, I think, in that. Because if you do that and you say that to your company, that I'm going to spend the extra money and the extra time to secure my system, but then these mythical, magical hackers out there somehow find some way to get past your security, it's your reputation, it's your job that's on the line at that point. And so you're almost, in some ways, from a personal, side, you're almost safer just to not to leave it alone and not make any, statements about security than to kind of put your neck on the line by saying, I am going to secure the system. So it really is kind of an interesting, situation and a tough situation I think we as engineers face, and we need to find a way with integrity, I think, to really push that onto what we're going to mandate in our own designs.
No, you know
So.
that.
But with all the embedded designs of the last 10 years really becoming, you mentioned connectivity and the whole Internet of Things. That entire term that we've all fallen in love with is, we're really spent a lot of time, with everything being interconnected, and it's making security just that much harder. And I think it's making hackers that much more capable and that much more advanced in some ways. With that, how realistic is it to really secure our designs?
It is. It is. I mean, the tech is out there. The tech is out there. At least on the embedded side, it's you got to start with the lessons. We got to start with your threat model, right? You define. It's like when you define a consumer any product. Really, you have a definition phase. Security starts with that. You define your security model, which is your threat model. What threats
Right.
are going to be the most impactful on your system? and you go through a list and then you prioritize them, and then you make choices that should be in line with the threat for your company, the threat for your product, the threat for your customers. And there are techniques in place that are not new at all. It's been used in the tech industry for a very, very long time. And that's what you see. You see a boom of third-party companies, labs essentially, that would come in and do those assessments for you. And of course, some of them would offer the testing that goes with the pen testing that goes with it. So that's got to be done, and it's not done. So let's start with the very basic stuff. And what those threat models will look at is if you implemented the security foundations, right? You're going to talk about the famous CIA, but let's go in the embedded side. And authentication comes first, trusting your firmware you boot from, having an update mechanism, encrypted communications. Those would be 4 fundamentals, and there's much more you can stack up to that, of course. But those would be, to me, the first 4 foundations to implement in the system. Again, if you look at your threat model, you ask those 4 questions, right? The authentication, the secure boot, essentially firmware update, and the encrypted comms. Have you taken care of that? And surprisingly, you're going to see the firmware update not always there. So there you go. You get a vulnerability that, and we've seen that so many times, even in 2023. Hey, been attacked, this is my attack. Yeah, can you update the firmware? No, I got a problem there. Just starting by the basic before getting fancy into multi-tenant and stuff like that. Just there, start with the definition.
Yeah. So I think, again, it comes to, or have you planned from day one what you expect to see? Have you really thought things through? Are we spending that extra time? If you do that, you've got yourself probably a big leg up on what a lot of other systems are doing today.
Yeah.
And I think when we're talking about security, a lot of us think it's about securing securing the device once it's actually in the user's hands. So we're securing the data that the user is generating and sending from one place to another, or we're securing the ability for the end user to really control the overall design and make sure that can't get in there. But intellectual property theft, I think, is also a major threat for us today, and one that maybe we don't always consider outside of, like you mentioned, those applications with the renewable, where the primary business model is on a renewable, and you want to make sure nobody else can go in and really kind of steal your renewable. How can engineers minimize that ability for others to steal that intellectual property that we've created?
Connected, I'd say. The vast majority of the IP theft at the firmware level that we've seen, it was hard to remediate from it because there's no connectivity to the device. Again, that metal detector, no connection. So when the counterfeiter just get into the hardware, the firmware, the mechanics, the plastic of it, and about to copy paste every single thing, how do you control that? So now you get into the supply chain, the legal side of things. It's extremely manual. Now with connectivity, you have the notion of remote monitoring, right? That comes in, and it might not always make sense from a business model standpoint, from a cost standpoint, but that's where IoT takes on importance. To be honest, we've seen so many of them in the past. I'd say 5 years. 3 to 5 years, I'd say this IP theft is just gigantic. If you look at on the web, you'll see companies, they'll claim they'll attack microcontroller 1, 2, 3, and 4. Essentially, they get the X file out of it. You send them a micro and X file. They'll openly market it that way.
Right.
So I think connectivity is not just connectivity, right? It's connectivity with security in place, right? Is how I don't think we'll ever solve that, and that's the nature of the beast in security, right? You're gonna correct something or prevent something, it will be defeated one day. You got to expect that. You'll have to live on this expectation. So, back to your points that you've made many times, right? When you have that security strategy, I'm gonna call that a strategy now. You got to make a security strategy that you'll scale across time, across your fleet of device, across your company. And those 3 layers are 3 things that needs to be intertwined. That's where the difficulty comes in. Because then, you and I have talked about, the engineers that implement security. Security is more than just a tech; it's a philosophy across the whole I was going to say a whole industry, yes, but also first and foremost a whole company. If you don't have that strategy company-wide, you're not going to have that business unit that does something, business unit 2 does, business unit 3 does something else, and then when all those companies probably get together, they don't talk to each other. And then guess what? This is where you have things like Matter, for example, they're trying to achieve, I said just trying, right, to achieve that. Whether I'll be successful or not is something else. I think I lost my train of thought on your question, though.
No, but I mean, I think you're going down the right road. It's interesting because I think where we see one of the areas of weakness in security is that connectivity piece, but there's also an aspect of it, to your point, where that connectivity actually can help us better secure our systems and monitor those systems.
Exactly.
What outside of that, if I were doing a hand drill of some kind, and I've got, let's say, a battery that I want to use, and I only want my battery to work with that hand drill, what are the solutions that Microchip has available to ensure that my battery is the only battery that's going to work with that drill?
Right. So we have actually it's quite we have a very strong presence in that market. You're talking about that replaceable, disposable, consumable type of products with a battery here that you're referring to. So we have those little secure authentication IC. We have a whole portfolio. We call them the crypto authentication ICs. Essentially, you'll send a challenge to the battery that'll create a response with cryptographic function and the keys that are stored in the batteries, and your battery is legitimate. We've had, I want to expand the answer to that because we've had customer feedback numerous times that think it's black or white, and to some point, yes and no, but there is an industry that I like to refer to, and I will today. It's open and public. It's the wireless charging consortium. If you think about it, you have a phone and a wireless charger, and what the phone companies have decided. So the phone is your decision maker, right? They'll decide. They will do more than deciding if the phone charge or not from that charger. That's authenticated. It's mandate part of the spec. They also have a gray area of decision. I think that's the clever part of the process.
Okay.
Well, they'll say, okay, you'll be charging at X amount of power if I can't authenticate you. I'll charge you at X amount of power if I can authenticate you. So again, you have a user experience effect there. So for the battery, for the cartridge business model, it's something we invite a customer to consider, to leave that in the middle decision making option to provide a lesser or better user experience to entice to make things compatible. Compatibility needs to remain there. So that's the tech we have, the crypto authentication IC. We've got a very strong presence there. And remember, I was referring to the medical markets and the consumer market, same philosophy, same devices.
Right. Okay, very nice. Yeah, and we've certainly seen that. I think the families that you guys have for secure key storage and things like that are really phenomenal and really make designs work very well. We mentioned earlier a little bit about some of the government legislation that's coming out, whether that be in Europe, and now we're seeing also California, particularly in the U.S., lead the charge on new legislation for securing embedded systems. How do you see that impacting design going forward, and what do we need to be considering today for our designs that will allow us to be in a position to meet those mandates tomorrow?
Yeah, so I've followed the standards, all over the world. If you see the European first, they're pretty. The intention is very. If they go where they want to go, it's going to be pretty strict. There's going to be pretty strict rules, which could be very good and very bad at the same time. I'll talk through it in a minute. The U.S. just released the Cyber Trust. I think it was last week, 2 weeks ago.
Right.
I'll start with the U.S. The U.S., if you read what the text of the White House says so far, it's voluntary for companies to have that label on their product. So the consequence of that's going to be the marketing game, right? Hey, I've got my Cyber Trust label. The others that don't, as a user, you get to choose. Where is that going to go? If you look at the UL certifications in the past, how much of a consumer is paying attention to, and I think you go from generation to generation, how much of that has been marketed through all the generations that are of consumers, from the early, the young generation in their 20s to the elderlies and everything between. How is that labeled, perceived, or even understood, or even aware of. So I expect there's going to be a lot of campaigns around that, at least from a U.S. standpoint. In Europe, they're trying to mandate things. They're trying to mandate, which is not a bad thing, and we've got to respect that in a way where, if you look at Europe, how ahead they have been, and still are compared to the rest of the world in security. Think about the payment industry. Europeans had that SIM card forever. I've always known a SIM card. I moved from personally. I'll give you my personal experience. I moved from Europe to the US. There's no SIM card on my credit card, so that give you. You're talking decades of delay there. So I expect something probably somewhat similar when the scales of attack are going to be even bigger than what they are today. I think certain mandates of security practices will be reinforced more rigorously in the US. The Europeans are trying to mandate the basic foundation. They have defined their pillars, which I think it's pretty well done. And will challenge the companies to, just like you and I have talked the whole time, define them right from the start. Then you have the other countries in Asia that are also doing a pretty decent job, in India, in Korea, in Australia. Those are the one I know of. They've inspired themselves from what the Europeans have done. So it's getting much, much, much better. So far, most of the standards are very consumer-centric. The Europeans are pushing towards consumer, industrial, and medical from where I left it off. So they're going beyond the consumer. They're also talking about the notion of distributors, the roles of distributors within the security ecosystem. So that's going to impact all the layers from the semiconductors to the semiconductor distributors to the end product to distributors of the end product. That's going to impact everybody. So I can see a raise of experts that are going to have to look into that to be able to sell product overseas. Yeah.
Right. Interesting. And I got to believe that's going to have a birth of a whole new set of third-party companies that are helping to, helping companies get through that certification process.
Yep.
So it should be interesting. So talk to me with that. I mean, with, whether we're doing it because of, new legislation or whatever it might be, if we're securing our system, there is a difference in the production process. Of taking our system and either programming our keys into the secure key storage, programming our firmware into a secure microcontroller. What's that process look like now? Because right now, if I've just got a simple firmware, I send that to my programming house. My programming house sends the chips to my CM, and the build goes on. How does the flow of production kind of change when you're really securing your system?
So I think you almost have the answer in your question there. If we have to dummy it down, I'm doing it out a lot. There are the two steps. There's notion of provisioning the keys, and there's the notion of programming the firmware in the microcontrollers. There's quite a few things in between, of course. And that's just for the embedded. I'm putting the cloud aside. The cloud is a completely different beast on its own.
Right.
So focusing on the embedded side, provisioning the keys, we work with Microchip, work with our customers and future, and we ask them, okay, we educate them on the importance of those cryptography keys, and they quickly realize that they shouldn't be in possession of virtually anyone at all, not even the developer ideally. So when you have a CM involved and you tell them, hey, your CM has the key, you could have some type of hostage situation from a business standpoint, I think. Because then if you want to negotiate with another CM, you move your design to another CM, what happens to your keys there? Imagine you're 3 CM down the road. Where are your keys from the first CM? What is he doing with them? Because he's got the prima donna of security. This is it. So what you see Microchip doing, we offer an in-manufacturing provisioning service. So as companies are buying our secure authentication ICs, we offer a service. It's not mandatory, but the vast majority of our customers that use your silicon use that secure key provisioning service. So that's happening in our factories. We've got certifications in place. So essentially you're basically dealing with isolated network, closed room under camera surveillance, on guard, all the goodness that goes behind it. So it's a very, very well controlled system. It works for us, and we've seen customers trying to do that, but the reason they they can't scale is the economy of scale. That's where you step out of the technology of security and get into the logistic of security, the business of security. It's the economy of scale. That's our product that we ship in the literally hundreds of millions, even billions at that point. We have that economy of scale. When you talk to a guy that's doing a gateway or even a consumer product, you're gonna run gateway, say 3,000-5,000 gateway a year. It's hard to have it's very costly to have such an infrastructure in place and amortize it. The guy that does 200,000 units on a consumer product, same thing, it's still too small. Talking hundreds of thousands versus billions, right? So that's where it works really, really well. And again, distribution partners like Futures are bringing even more scale into that business ecosystem. So the key provisioning, the secure key provisioning service that Microchip offers is part of the foundations, because if you have your keys into your securement, that's good, but how do they get there? It's a big supply chain challenge there. And then you have the programming of the firmware. Microchip also provide a firmware programming service for all microcontrollers. And that, again, I'm going to reach your point that you alluded to many times, that you start to see third parties coming into that game. And you want to ask the question, how well do they do it? How do they do this? And then when you get into the nuts and bolts, you understand the holes and the problems of scale, because they are often limited to scale from, you need to cover every CM in the world. That's the holy grail, right? So companies like Future and Microchip have that economy of scales with the channels you guys have, the supply chain lines we have in place. They are made to address those type of global challenges.
Right. And I think that's where we've got to really stand in the gap there. And we've spent time, I know we've sent a number of our engineers to spend time with your Microchip factory engineers and learn more about how we go through that entire production process of securing. And that's something that we're here to offer to customer engineers and engineers that are doing systems and want to work with us. We'd be happy to share that expertise with them and kind of be a guide to walk them through that entire process, because it is a little bit of a brave new world. And it does take a little bit of learning, and it's not something that any of us are going to know on day one until we've really gone through and done it. So, but this is absolutely fascinating topic, and Xavier, thank you so much. I really appreciate your time, and sharing some of your expertise with us. I think we could probably talk about this for another couple of hours and still only skim the surface of all that there is when it comes to embedded security. Thanks so much to our audience for joining us on this episode of The Current. If you have an embedded system that you're trying to secure, if you have questions on how to do security, please feel free to reach out to us at Future Electronics at Shaping the Future, one word, Shaping the Future, at futureelectronics.com. We'd be happy to speak with you, get some of our local engineers to meet with you, and help you get to a point where you feel confident that your design can be secured. And we can also help you with a lot of other areas of your embedded design if you have those needs. Thanks so much for joining us on The Current today. We'll look forward to seeing you on our next episode.